Time to start up, everybody. First of all, thanks for coming to the semester's first Virtual Simulation Lab seminar. Today we're going to have a talk on revision control with Git, given by Anders Lervik here from the Department of Chemistry. And you saw the cartoon that Anders put up at the beginning. I'm sure many of us have all been in that situation where we have 50 different revisions of the same document, and it's quite difficult to keep things in order. So Anders will talk about Git, which is a tool that we use to keep all our revisions of certain documents, especially programs and things, in order. So why are we doing this? Again, this is the only time I'll give the lecture this semester, even if I did it last spring twice. When you're working in modeling and simulation, there's a small gap between your academic experience that you would have if you worked in the laboratory. The laboratory, the inherent nature of that environment, gets people all to come together to a single place. The people working in the lab, they get to know each other, they work together, they teach each other things, and they learn from each other. Yeah? And even for a piece of lab equipment, they have a yellow card above it. And it says a person responsible. If you have questions, go talk to them about it. They can show you how to use it and things like that. So, for modeling and simulation, though, it's a different story. We spend most of our time in the office, sitting in front of the computer. Yeah? The work we do is mostly our own. Yeah? And we don't get to go into a similar environment with other students doing that kind of work that we do on the computer. And we don't get to talk and interact as much. Yeah? So you're mostly working alone at the computer. We learn the new techniques on our own from the web, forums, help files, things like that. But we may or may not effectively pass it on to other students. And that's one of the key points here, is that we work hard on the computer. We do things that we ourselves think is clever, but then you go to the project meeting, you go to the conference. Nobody wants to hear about the clever things you do on the computer. They just want to see the results, right? Well, here, if you've got something clever that you think you've done, you can share it with other students, you can teach them, and they can learn from you. And also, in here, we get to see each other's faces. We all know who's kind of working on the modeling and simulation. Afterwards, we're going to eat some pizza and stuff, and have some drinks, and soft drinks, unfortunately. But still, we can get to know each other and maybe develop networks where, oh, I know this guy or this girl, and maybe she can help me with the problem, and call them up, send them out. Just break down barriers, break the ice. So that's what we're really trying to do, because within each and every one of you, there's a wealth of knowledge that's scattered among you. So the idea of this thing is to sort of bring it all together and keep it in a place where you can access it and sort of have people you can turn to help for different things. How does this work? Well, there's basically three things we have, or two major things that is important to you guys. We have our seminars, which we advertise, and we talk about different things, a lot of making advanced graphics and things. We can talk about more detailed stuff about coding, using computational infrastructure at NTNU, concepts in software development, and so on. So lots of things that we would deal with on an everyday basis, but things that nobody wants to hear about again at the conferences or at the project meetings. And then we've built a website. It's still sort of in a rudimentary form, but it's getting there, and we're adding things to it every day. This is the address if you want to go to it. And we'll do all our seminar announcements there, and we'll give you background information, like if you want to. Today, Anders, he gave you instructions on how to install Git, so if you went to our website, you could have seen that and installed things. You can follow along with him in his lecture today if you've done that. And also, you can see Eirik here from the multimedia department is recording everything. So we're also going to put links to the seminars up there. So if you miss it or anything like that, you can come and watch it and see it. Yeah. And then, like I mentioned, those yellow cards before. The people who give the seminars, in this case Anders for Git, they will sort of act as a person responsible that if you have a question or something simple to ask him, maybe you can just send him a quick mail and he can direct you to something. But again, we don't want to make our presenters overwhelmed with the work they do here. They're quite already put in a bit of effort and time to make the lectures and go over them with us. So we don't want to overwhelm them, so don't overuse them too much. But definitely, if you have a question or something like that, just give them a shout. Everything like that. So that's basically it. So what is the outcome? Well, hopefully you guys will get a broader education. You'll at least be familiar with more tools, more software, and more types of coding, more scripts that you can use when you go out and leave the university and start your careers. Hopefully we can improve the quality of our reports, our figures, our deliverables to industry through this, make better codes, whatever, and build the social network. Get to know each other, get out of our offices, get away from the computers, and see who's out there doing the same kind of stuff we are. So if you like this and you think that this is a good idea, the requirements are just that we have a steady stream of lecture seminars. Yeah. So if you guys have good ideas, let us know. Yeah. And then participation in seminars is also really important. You can again find out about the seminars at our website. We have a Facebook page. If anybody's on Facebook, go there, give us a like, and then all the lectures we have will also be scheduled. You can say if you want to come. That will help us plan how much food to order and stuff like that. Our goal is to get 50 likes. We're at 25 right now, so if you have a Facebook account, go there and give us a few likes. Twitter, yeah, I don't know. Maybe we do it, maybe we don't. I don't have a Twitter account, I have to admit. And then we have the evaluation forms because, we're sort of going on the wing here, so your feedback is important to us. So you fill out these forms, we take it seriously, we consider it seriously, and we try, based on what you tell us in the feedback forms, to sort of mold these seminars and the website to what you guys think you would like to see, or what you think is working and what's not working. So please, we've left the forms there. We have some pens scattered around if you don't have any pens. There's a cup there and a cup in the back. So just please fill out a form and then give it to me at the end, and we'll take your feedback into consideration and try to get you the topics that you want to see. Okay? So I guess I spoke enough. There's the next seminar. The seminars are every 2 weeks this semester. Next one will be 24th of September, and this will be Sigva Karolius from the IKP, and he'll be talking about Markdown and Pandoc. So that should be interesting to see. So, okay guys, without any further ado, I give you Anders.
Yeah. So, thank you very much. I will start by going back to this picture, this situation that maybe most of us has faced at one time. And this is actually how I got into really using Git, because I was in this situation. The only difference was that I had 2 professors, which of course made the mess 3 times as large. And it became clear that no matter how clever we were with the file names, and maybe we looked at the times we changed it was not powerful enough, so we needed to have something better. And then that better tool was in that case Git, which we use for version control. And that is what I will be talking about now in this lecture. So by revision control, I just mean something that keeps track of the change to a set of files over time. And in this figure here, I will sort of try to picture that. So all these letters, A, B, C, D, and so on, they are just different versions of a file. And they all point back to where they sort of came from, to their parents. So for instance, I started with this letter A here, version A of my document. I sent it to my 2 co-authors. They started making changes. And for instance, my co-author 1 took version A, made some changes, and it evolved into version C. That was that. And I took the document still in version A, did some changes, and then it evolved into version B. And the same for co-author number 2. It took the first initial draft, made some changes, it turned into document D. So my co-author 1 then said, okay, I'm finished, done with the changes, I'll email them to you. I got that, version C, and I combined it with my version B. I merged them together to make version F. So we have sort of combined the work of the two of us. And then my co-author number 2 said, well, I'm done. I'll just email you my changes, which was version E in this case. Send it to me, and again, I could combine it with what I had at that time. So the reason why I'm calling myself master in this case is not because I was the most important one. This is just the standard name in Git for the sort of main branch of a thing. And I will refer to all these white boxes as different branches or projects. So in this case, there were 3 of them. And this one, the initial draft I have written there in this pink little box, that is just a label. So I planned this seminar sort of interactive, so I will give you some examples or tasks to try. So if you have got a computer, it would be nice if you power it up and get it ready. If not, maybe you can sit next to someone with a computer, or at least I will definitely show you the steps. So you will at least see it, even though you don't get to try it. So to introduce Git, I just copied the first sentence from Wikipedia, which says that what Git is. So I just highlighted some of the words which I think are important for Git. So it's a revision control system, which means that it tracks changes to a set of files over time. It's distributed, and it supports nonlinear workflows. So distributed means that if I have a copy and if you have a copy, they are basically equal. So if I lose mine and you still have yours, we can still sort of recreate our project because it's still there. Nonlinear workflows means that many people can work together in collaboration. And that makes it sort of easy if you, like I did, if you work on one document where many people have to do changes at it to the same time. So just to give you sort of the background where it comes from, where Git started, it's very closely connected to the development with the Linux kernel. In the beginning, they just passed changes around, and someone had to make sense of the changes and update the kernel. At some point, they started using a free program called BitKeeper. So it was free as they could use it without charge, but it was closed source. And of course, if you give something closed source to these people, they're of course very curious, and some years later, it was reverse engineered. So they basically made their own version of that program, and that was not very popular for people making BitKeeper. So they withdrew the free use, and then Linus Torvalds was sort of stuck. What should he do now? He found out that he didn't like any of the other version control systems available at that time, so he just started writing his own. And that means that Git, from the start, is sort of made for a big project with many files and many people involved. It scales very well. But also, it is usable for smaller projects. And just to get what it really means out of the way straight, it basically just means Git. Git means Git. It's nothing special about it. But since the start in 2005, it has become really popular. And it's been being used by all these big companies who do work on source code. And maybe some of you have already used it if you have downloaded some programs from these two sites, for instance, GitHub or Bitbucket, because they are basically using Git with some web interface around it. So what do we have to learn in this talk? So Git is actually very complicated, like in this picture, but most of us are able to drive a car without knowing too much about the different parts, because there are really many, many parts to Git. It's command-driven, so if we want to learn all the commands, we have to learn 150 of them. And then in addition, we have to learn all the different options to the different commands. So of course, we can't do that in less than an hour. So what I will do is just to show you about 15 of them. Well, the most important ones. I have written them down here, so you will remember them, hopefully. And I will not go into great detail on how Git actually works, so the internal mechanics. So we will just turn the wheel and honk a bit. That's all for now. And we will approach it in 3 steps. So I call it linear, and with branches, and with remote. So linear is basically just doing changes in a chronological order. So things happen after each other in time. My version A turns into version B, turns into version C, and so on. But then we can do it more structured in a way with branches. So here I just have one example where one person is, say, working on his PhD thesis. And he decides to separate out whatever he does in different experiments in different branches. So, for instance, at some point he's starting his work with experiment 2 and maybe doing some work, and then he finishes that. Then he decides, okay, I can put that paper, whatever outcome is, into my thesis. And that I have represented here with this merge. And remember now that these arrows, they point toward their parents. So this one, for instance, H is made by a combination of E and C. And the last thing I will mention is how we can collaborate with other people. And that I will refer to as working with remotes. So basically, the idea is that you can pull in changes from another project. That other project could be some Git project on your own computer. It can be Git program on that computer. It can be on some server somewhere. So it's basically very free when it comes to collaboration. You're not bound to using some central server somewhere. Okay, so now I will start with taking the first steps with Git together with you. We will just discuss this linear approach where we record things in chronological order. So the first thing we have to do when working with Git is to actually set it up in a way. We have to initialize the storage of our project. And that is done with this command, which is called git init. It actually does something very specific. It will create a folder in your project directory, and that folder will now contain Git, or it will contain the history of your project. Just to show you what it looks like when I do it on my computer. So now I am inside a completely empty directory. There's nothing there yet. I will just simply initialize Git by typing git init. So it just says that, well, now it's initialized. And what does that mean? Well, if I look now, there is a new folder there. And I can also just quickly look at the contents. It's set up with a lot of different files and directories. So I will not go in detail about what's really in this directory. What's important now is remember to never delete this, because this is now your storage of your project. So just keep it there for now. And now, this git init is really something we do it only once for each project, then it's done, and it's there. And what we then need to do actual work, it's these two commands, the add and commit. And that's going to be sort of our mantra for today, add and commit, add and commit. So do it over and over and over again. So in a few slides, I will try to explain you why there are two commands like this. Why is there not just one and what's really in the commit? But before that, I would sort of just show you what it looks like when I use these two commands, just to sort of get it into our fingers. So this is now the typical workflow we will be using in this approach. We will do some work, we will add the changes, and we will check if the changes are okay. That could be if you work on a program, you want to see that your program maybe is still running, and then you store the changes. And store changes is done in Git words with git commit. So here you see I have sort of separated out the add and commit and saying that I do slightly different things. I will explain this more in detail in a few slides, but first I will just show you what it looks like when I do it now. So I will, let's see. So I will just create one file. I will add it to my Git repository and then commit it. So I first do my git add, and then I do git commit. And when I type this git commit now, I'm met with this screen. So it's asking me to enter something called a log message. And that is something which goes into the log of the project now. So I can look at the log and see what changes have been done to the project. So I've just typed something. I have added my first file. and then I will display the log. I haven't told you about that command yet, but maybe you can guess what it is. Just git log. So as you can see now, this is the message I wrote. I added my first file. It tells you who did it and when it happened. And there is also this strange number which can be used to identify this particular commit. But I guess you maybe are burning with questions on what is this commit and why do we do adding commit, and just wait a few seconds more, I will tell you about it. But if you have a computer now, I would just like to challenge you to try these 3 commands we have been looking at. The git init, and then try to add a file by using git add, and then try to commit it. And well, as Git is mainly done working with the command line, and some of you might not like working with the command line, I have also written down this web page, which is a more sort of visualized approach to learning Git. So in this one, you can try out to see what happens visually when you do a git commit. So I just show you that web page quickly. So here there are some more details I will tell you about in a second. But if I now type this git commit command, it basically just shows that my system, or sorry, not system, that my project is evolving in time. So something new happened, and I made a new commit. So I will just give you 1 more minute to try this out if you have a computer. Okay, since there are quite a few people without a computer, I can again just show you how this works. So I will just make a change to this first file. So let's see. That's a very wrong command. Okay, so I want to make a change to this file. Hello world I wrote. What about hello Git? And then the question is, well, is this stored now? And the answer is no, not yet. I have to add it first. But I will just write a new command, actually, which I have not told you about yet. It's called the status. It just displays what's really happening in this repository. Well, so actually Git notices that my file has changed, but I have not added it yet. So that's displayed there in red, if you can see it. The file has been modified, and it also tells me that, well, these changes are not staged yet. That's just what you call what you're doing when you do a git add. And it says, well, you can use git add to add it. So let's do that. I'm adding this first file, and I will just check the status again. And I'll see that it has changed. It's green and nice, and it says that, okay, I have a modified file, and I have added these changes. And now, if I want to keep these changes, I do the git commit. So let's try that. So this is a bit maybe redundant, this message I'm writing, because that's really what's happening now. But still, it's very descriptive of what I did. So now I've done 2 commits, and my log contains 2 items. But what is this commit really, and why do we do add and commit? So this commit is actually, you can think of it as a snapshot of all your files. And when you are doing add, you are sort of adding files to a queue to be committed at a later stage. To give you even more details, I have to discuss sort of the periodic system in Git, because that one is very easy. It just contains 4 items. You have the commit, so that's actually an object. It points to a tree. It contains a timestamp, log message, and an author. And it contains a pointer to its parents. So that pointer makes it possible to have a history in time. And you have already seen that it contains the author, it contains a timestamp, and there is a log message. But what is this tree I wrote there? That's actually just a list of items, and the items can be other trees, or it can be something called a blob. So this is very similar to a directory. And what is this blob? Well, It's a short for a binary large object, which is basically the same as a file. And now you can see that these three items together basically gives you a picture of what your files and directories look like. So that's what's in this commit. And the fourth item is one I'm not going to use very much, because if you noticed, this is actually a pretty long number to remember. Usually you can get by remembering or using the first 7, you don't have to remember it. But if you do a tag, you can exchange this for something more human-friendly. You can call this is version something of my code or whatever. So it's basically a way to name these commits. And just in picture form, how these different things relate to each other. So I have the commit here, and I've chosen to give it a tag. It points to a tree. That tree points to another tree and some blobs. And this is basically a picture of my files. And then again, I have the structure where this commit, which I call now B, points to its parent, A. And with even more detail, if you are really interested, here I try to list what's actually in the commit. It points to a tree, it has some parent, there's an author, which may be different from whoever committed it, and there is a message, and then you have the trees and the blobs. But then you might ask, why do we need to do both add and commit? Couldn't we have just done everything in one operation? And the answer is, of course, yes. But Git is it's by design like this. So when you add files, I like to think of it that you're sort of saying that, okay, I want that file or change to be a part of the next commit. So I think of it as you're building your next commit. And the next commit is what's now going to be stored. So you just try to picture it here as you're taking a file, putting it into a folder, and then you do the commit, you're putting the folder into your repository. So when you're putting it into the repository, you're also giving it a label. It was this long number I showed you, so you can refer to it later. So the truth is actually a bit more involved, because git add is actually what's copying the file into the repository, this .git folder, but that's a detail right now. So this is the sort of the picture I have of the different operations. And of course, there is something missing here, and that is, how can we go from this repository back there if I want to see the changes I've done previously? And that is now a command called checkout, which I will again show you in a few slides. But first, I think if you have a computer again, it's good to try add and commit just to get used to it, how it works. So try to add a new file, but in a new directory this time, commit it, and then remove another file. And I haven't told you how to remove it, but I suggest that you try a command called git help, which gives you a list of the most used commands, and there you will find how to remove a file. So I think I will do this now at the sort of same time as you are doing it, so you can follow me if you like. So the first thing I said was, let's try to add a file in a new directory. So I just make a new directory, and let's see if this git notices that. No, it does not, because it does not care about empty directories. So directory is really, it only cares about files. So I actually need to put a file into that directory for Git to notice it. So I will do, let's create a new file. And then I need to add it. Oh, let's do status first, just to see what happens. Well, Git notices that there are an untracked file, but it does not really know where it is yet. So I have to tell it. So I added the file, and I do the status again, and then it is now added.
So you don't even have to tell it a directory path?
I did implicitly because I was in the correct directory.
You went into the
And then I need to do the commit. Just to check the log, I have a new entry now where I've added a new file. So the second thing I told you to try to do was to remove file. And that, in order to figure out how to do that, I said you can try the git help. And this one looks very promising, I would say. Yeah. So let's try it. Oh, gir. That's when you're angry. Okay. Seems to be working. Let's just check the status again. Well, it's not completely there yet because I have to now commit for this change to actually take place in my repository. So I will do that. So now the change has been done. This directory with the file has been removed, and I have a log entry about removing that file now. Okay. So if you're trying this, you might actually accidentally have deleted the file, and then you might wonder, how can I get it back? Or what if now I want to look at the previous version of this? Then I had that another file before I deleted it. How can I do that? And then I come back to this checkout command, which I showed you a couple of slides ago. That's actually how you go back in time, so to say, or how you restore deleted files. So I will just show you now how it works. So let's say that I just try to accidentally remove this file and I want it back. Well, it's actually very easy. I just have to write git checkout and the name of that file. Oh, I can do ls first. Oh, it's gone. And now it's back. So basically what I did, I went into the repository, picked up the file, and brought it back. But now, what if I want to look at one of the previous commits, what they look like? And then the answer is again the same command, git checkout. But then I need a way to refer to the commits. And that is actually these long numbers. So if I now want to, maybe I want to look at this one where I actually added a new file, I will have to do git checkout, and I have to use this number. Usually it's enough to use maybe the 7 first of them to completely identify it. So I'm not sure if I actually managed to pick out 7 letters, but let's see. And now I went back to the previous version where I had this directory with that file inside it. Okay, so how can I go back? Well, I use checkout again, but now I need a sort of magic word, which is master. Okay, so now there were actually a lot of things going on while I showed you this. First of all, how did I know that master was the sort of magic word to use to get back to the right place? And if I move up here, I get a message that does not sound very nice. You have a detached head, and head are supposed to be attached to something in general. So that sounds very, very wrong. So what's going on? What is this head, and why did I use master? Well, it's actually not so complicated. Checkout is actually moving something which points to where you are. So it moves this head, which is a reference for a point where you are, to another location. So I tried to show it here in this picture. So I have my version C, where I have head pointing to something. I write g checkout b, and what's happening then is that the head is moved around and points to this b. Fine. So checkout moves just head around. And what is this master? Well, master is actually just something that points to the most recent commit in the branch you're on. And that is just a default name for that branch. I haven't been talking about branches yet. That's the next topic I will go into. But for now, we can just remember it as a way to get back to the most recent commit. So I think here it's maybe better to see it visually. So here I have done some changes. I can do another git commit. And as you can see, when I do that, the head and master then move along, and now they point both to the most recent commit. So what happens now if I try to check out something? I can try to check out this first one. Well, I'm basically just moving head to point to that location. And now if I do go back to master, you see that the head is moving again. So when you do the checkout, you're just moving this head around, basically. So that was actually all the things I wanted to talk about in this first part. To summarize it, we do this add and commit to store files. We can always check out previous versions. We can view the status. We can view the log. And we have this head, which is just a symbolic name for the currently checked out commit. And then I again have some tasks for you. So now I have one for you. If you don't brought a computer, we can try to maybe discuss with the person next to you, try to explain what's the difference between add and commit. But if you have a computer and prefer to try something, try to make some changes, try to add them and commit them, and then try to check out a previous version. So I'll give you a couple of minutes to try that. I caught a beautiful explanation on the difference between add and commit. I heard it over there actually, so I don't know if you're willing to share it. It was a picture. I loved it.
Yeah, well, yeah. I said that I think I have to admit I've seen this lecture before, but the commit is like taking a picture of your project or whatever you're doing at that point and saving it. But the add is sort of building your picture. You're saying I want this file in, this file in, this file in, and then you get it. You know how you get everybody lining up for a snapshot. You know, and say cheese. So that's the add command, and then commit command is to push the button on the camera and take the picture, and then you save it there. So that saves the state. The add tells you what you want in the state that you're taking the picture of.
Yeah, I liked it.
I think it even improved from the first time.
Okay, so it's time to be more structured, and that is done with branches. So there's actually not so much new things to learn now. Just a few more commands, and we will be looking into these 4. So in this next part of the talk, there will be just 4 new commands. So we need some way to create our branches, we need a way to interact with them, move into them, and we need some ways to merge. But what can we use branches for? Well, it's great for structuring your work. So let's say that you are working on maybe a plotting tool, and here in your master branch you're working on a 2D version of the plotting tool, and you are really satisfied with how the work is going, it's going really well. Then you decide, okay, I should include some 3D plotting capabilities. And how can you do that without breaking your perfect 2D plotting tool? Well, you can make a new branch where you start developing this new 3D plotting feature. And this is actually the idea behind the branch. You branch off something, continue developing that branch without interfering with the main or master branch. But then at some point you say, okay, I want to include my 3D plotting tool with my 2D plotting tool to make an even greater plotting tool. And then you do the merge, where you basically take the different versions and combine them into one. So we will look into how to create the branches and how to merge them. So to create them is actually very simple. It's just one command, git branch, and the name of the branch you want to create. And then we actually know how to move into that branch. That's just the checkout command again. Checkout is sort of our magic command for moving around. So I think I'll try to show you this with this visual tool, what it looks like. So I will create a new branch. I'll just call it test. Well, a new yellow box appeared. I have created a new branch. And I will do a git commit. Well, now my head is actually still pointing to master, and that's why now the master is moving. I have not moved into this new branch yet, so I have not done any work in it. But let's move into it. And now it was this checkout command which will move us into tests. And here I can start working and do some commits. And as you can see now, the history is starting to diverge. I have a new branch, and I can now switch between these two branches for working in parallel. But then at some point in time, you are perhaps happy with the work you've done and you want to merge it in. And then you need a new command, and you can see that it's quite cleverly made git merged. So that is used to merge something into the branch you're currently on. But you can also do something which is called a rebase. And that is, you can picture it in a way as the opposite way. You're taking the branch you're in at the moment and sticking it into another branch. So I will just show you what it looks like, what the difference looks like. We can just, maybe I should draw it too. So when you do this git merge, you are, as I said, combining different versions. So if I go to not my first, but the second slide, git merge is actually what's happening here. If I've done a rebase, it would look slightly different. This C would actually appear to have happened after the after the B. So they would be after each other in time. So that's the difference in the outcome between a merge and a rebase. When I do a rebase, everything looks linear. With a simple merge, there are still branches. So some people, they prefer to do the rebase because then everything looks like it was really well thought out, well planned. Everything happened after each other in time. It looks very clean. Some people don't like doing it because it's like you are in a way faking the history, right? It looks like something happened differently from what it actually happened. But that's basically just a personal taste of what you would like to present. What might happen when we do this merge is that we might have in these two branches a file, which is the same file, but there might be some differences in the two versions. So then the question is, which version of the file should I keep? And that is called a conflict, because Git does not know which version you want to keep. And this is something you have to sort out. So I will just try to make a conflict and show you how to resolve it. So I will just first create a branch. Let's call it test. I will move into that branch. And it seems to be working, yes. So I will open this first file, make some changes, add them, and commit them. So as you can see, when I do this commit message now, it actually tells me which branch I'm on, so I'm not completely lost. So I've done one change. So I will go back to my master branch. I will look in this file. Add my changes and commit them. And now I'm on branch master, which is where I wanted to be. And now I can try to do the git merge, where I pull in the changes from this other branch, which I call test. Oh God, there is a conflict. And this is something I have to resolve. Luckily, Git tells me where the conflict is. It is in this file called first file. And now it looks slightly annotated. So Git is actually now showing me the file in the two different versions at the same time. So now I can change it. I can make it into what I wanted it to be. So I will just delete some of the text. Maybe I wanted it to look like this, say. And now I can simply add the changes again and commit them. And I will just keep this message. So now I have merged in some changes. I have resolved one conflict. And this is, in a way, the typical picture of what happens when you're working with branches. You will often get this kind of conflicts because same file might have involved in different ways, and then you have to resolve it in some way. So I think we'll in light of time, I think we'll skip the first part of this example, but just try for a few minutes to do the last part. Can you think of a good use for a branch in the project you are currently working on? And well, try to explain the difference in outcome between emerge and rebase. And that is actually very much simpler if you can access this web page, which I tried to go into but failed at, because then you can actually see how they differ. So if you try for a few minutes on at first thinking of a good use for a branch, I will try to see if I can get this web page working again. So I think actually we'll just continue. And actually I'm at the summary of the parts about branches, so I will just summarize the commands we have seen now. It was the git branch to create the branch, checkout to move into it, and then you have two ways of merging. We can either merge or we can rebase. So for the final part, which actually will be quite short, there are some new commands there at the left part of the blackboard. I will just discuss some options for collaborating with others. And that basically means that we have to have a way of sharing our work. We have to have a way of connecting to each other. But the actual picture of what's happening is very simple. It's very much like having a new branch. So when you are connecting to a remote can be another computer, it can be a director on your computer, it can be another server. So it's basically just a new branch in your project which then syncs with the remote. So with a picture, it might look like something similar to this. So in the top here, I have my own project, and then I have another branch with a special name. It's called origin/master, and this is just a convention. Origin is just a name of someplace else, a short name which is easy for me to remember. If I'm working with someone called John, say, I could call this John. And master is just the name of the branch on that place. So if I picture that I can look at that place, it might look like something similar to this. Origin is the name of the place, and the branch master. And now I have connected to that branch up here. So I can, in a way, track what's changing and what's happening in the remote. And how do I do that? Well, first, I have to connect to the remote, and this is done in this way. It's a new command, git remote add. Short name. This is something I decide, something that's easy for me to remember. And then the address of the place I want to add. And that is typically something like this, for instance. So if you have your laptop, you can try adding a remote repository to your project that you're working on right now. It should be just writing git remote add, your short name, and the link to the repository. But after you have done that, you basically have just set up a link to the place. You have not interacted with it yet. And that is, again, a new command. So now we are actually nearing the end of all the commands I will talk about. It's called a fetch. And that is going to download data from the remote. And the way you use it is git fetch, and then you write then this short name you defined when you did the git remote add. So it's the same short name. So it's just a way of referring to where you want to download it, rather than writing this long URL. And then you can decide to maybe merge in the changes from the remote. Or you can do some work, and then you want to maybe upload it, and that's a command called push. I'll not go into details about it right now. What I rather would tell you about is something called a clone. This might be something that many of you already have done if you ever had downloaded code from GitHub, for instance. Then you're very often asked to clone something. And this is, in a way, a very standard way of sharing code. When you do a clone, you will not only download everything, the whole history of the project, you will also set up some links. You will set up something called origin. And that origin automatically points back to this place. So when you now do a git push, as I said, it automatically knows where to push it. flash this a bit too fast perhaps, because here I wrote it like you have to specify it where to push it. You have to write the remote name and the branch where to push it. But if you do a clone first, it automatically knows where to push it. And then when you download data with this fetch command, you can actually replace what you typically do, because it's very common to download with the fetch and then you merge in the changes to your local branch. That can all be replaced by one command, which is simply called git pull. This is just because it's a very common way of actually working. You push and pull to the remotes when you have cloned it. So here actually we're hoping to show you some fancy examples with this visualization, which is not working on my poor computer at the moment. But if you have time, I would strongly suggest that you try to check it out, this web page, because they have some small exercises which you can try. So we'll see how push and pull and fetch and merge and all this work in practice.
You have 30 seconds to connect it to the internet.
Right, I think it's fine. And that was actually all the things I wanted to mention in this talk. So when I was thinking about what to do for a conclusion, I didn't really know, because I don't want to conclude that Git is the right tool for you to use. This is something you have to decide yourself and try out. Maybe it's not for you. Maybe you prefer to not use version control at all because it's too tedious to work with all these commands. Maybe you want to try something else. There is another program called Mercurial, which is very nice. But don't use SVN, whatever you do. That's all then not very good. So actually I will end now with this bad poem I wrote about Git. So, to work with Git, first do init, and remember you add before commit. Branch often early, merge and leave early, and if you're in doubt, you can always check out and follow the previous route. Push, pull, and fetch. I know it's a stretch, but I hope this serves you as a sketch of Git. So, thank you very much. And these are my steps. I will highly recommend this to Laser, and especially this last one. It's more or less a game for learning Git, so you will really learn how to master the branching. And if you have questions, we can maybe do it when we eat pizza, because I think I'm slightly over the time. Thank you very much.